Good afternoon. Welcome again to Mathematics Solutions. And today we want to solve or we do the revision of engineering mathematics topics such as uh, complex numbers. We'll have also hyperbolic functions. And also we're going to have some introduction of differential calculus. But in the beginning, there is a request to solve a question on PDF, probability density function. So I'll start by that. And I write it down so that I can help the student who have already just tested. Thank you very much. Kindly, if you have not subscribed to this YouTube channel, kindly just subscribe, you like, and you share to your colleagues or friends so that it can also help them. Thank you very much. Thank you very much. Please share to your friends so that they can also benefit. So I hope my audios are clear, and I hope everyone can be able to get me clearly. So we have the question. Student, I'll just send it. So I'll definitely write direct from how the student have sent the question so that you can help him. The question is a continuous random variable x has probability density function has probability density function f of x given by f of x is equals to k exponential -3x and 0 elsewhere. So the range of the first function is that x is greater or equal to 0. So that implies that the value of x will be running from 0 to infinite. So determine Roman number 1 the value of the constant k, the value of the constant k. Roman 2 the mean, and Roman 3 we have probability x within the range 0 to 0.5. So we shall go direct to the solution of this problem. So we change the color of the pen, we say solution. So to determine the value of k, we need to understand that some properties of a PDF, and understand that the property of a PDF, we have a property such as the integral from -infinite to infinite of f of x dx is equals to 1. So this is the property that you're going to apply in this case. So we are going to have our f of x is k exponential negative 3x, and in this case we're going to have the range for our problem. Also again, this one property of a PDF. The second property also we have that the probability x is from a to b is equal to the integral from a to b f of x dx, and this will be equal to 1. So in this our problem, we're going to apply the condition number 2, despite we have another third condition that we say this f of x must be positive for all values of x. That is, f of x must be positive for all values of x. For all values of x. For x, this f of x must be positive. So we can proceed and have our question here. So we have our f of x. Our f of x is equal to k exponential negative 3x. And so for Roman 1, you can say the integral from 0 to infinite k exponential negative 3x dx should be equal to 1. So in this, you'll be applying the condition number 2. Applying condition number 2, and so we're going to have, when you integrate k exponential negative 3x, you're going to have negative k over 3 exponential negative 3x, and then the ranges is from 0 to infinite, and this should be equal to 1. So we want to put our ranges together, or we want to substitute our ranges. So we need to note that exponential raised per negative infinite is equals to 0. So this one, you need to note this. And so it means that if I take negative multiplied by infinite, x being infinite, then I'm still going to have negative infinite. So it means that when I substitute my infinite, I'm going to have negative k over 3 exponential raised per negative infinite. Then now we subtract, when we substitute, now 0. Our lower limit is 0, so minus negative k over 3 exponential raised per 0, and this should be equal to 1. Well, the reason I put it 0 because when I substitute 0 to x, I'm going to have negative 3 times 0, and that implies that I'm going to get 0 in the power of exponential. So we have already said that exponential raised per negative infinite is 0, and also again, you also need to note that exponential raised per 0 is equals to 1. So the whole part of this one here, it will be negative k over 3 times 0 minus, so it will be plus, it will be affected by this negative, so it will be plus k over 3 multiplied by 1, because exponential raised per 0 is equals to 1, and this will be equal to 1. So negative k over 3 times 0 to be 0, so we're going to have k over 3 is equals to 1, and this implies that k will be equal to 3. So that is for Roman 1. So you can check our Roman 1 what it wanted to, it required us to look for or to find the value of the constant k. So we can go to Roman number 2 and the mean. So Roman 2 to find the mean. Now in PDF, the mean is the same as the expectation of x. And understand that expectation of x is equals to the integral of x, p x equals to x dx. And this being a probability density function, then this probability here is the same as the f of x. And so we're going to have e of x being equal to the integral of x, f of x dx, and then running from 0 to infinite. Because we've been given our range as, for this function, our range have been given that x is running from greater or equal to 0, so it will be running from 0 to infinite. So on the same case now, we're going to have now the expectation of x is equals to the integral from 0 to infinite of x, f of x. Our f of x is k, it is k exponential negative 3x. And that means our k, we have already the value of k being equal to 3. So we're going to have x multiplied by 3 exponential negative 3x, and this dx. So we can factorize 3, it's a constant, so you can have, or else you can have expectation of x is equals to the integral from 0 to infinite 3x exponential negative 3x dx. So in this case, we have the product of two functions. We have the product of this polynomial 3x, and we have the exponential 3x. So in this case, we're going to integrate using integration by parts. And so we're going to have, we're going to let our u be equal to 3x. So this means that our dx, our du dx will be equal to 3. Will be equal to 3. And this means now our du is equals to our du our du 3 will be equal to dx, like that. And then now we shall have our dv being equal to exponential. So dv is equals to exponential negative 3x. So this implies that our v will be equal to, we shall integrate both sides to get v is equals to negative a third exponential negative 3x. So we should substitute, because we know that integration by parts states that the integral of u dv is equals to uv minus the integral of v du. So, and from that case, now you can say the integral of 3x exponential negative 3x dx is equals to, and this runs from 0 to infinite. Let us not forget the ranges, the limit from 0 to infinite. So we're going to have our u is, so I can change the color so that you can have a difference. So this one is our u, this one is our v. We have our v there, we have our u here. So we substitute here uv, so it would be negative exponential negative 3x. Why? Because if I take this 3 for u and negative 1 over 3 for exponential, I will get negative 1. So that's why I've remained with the negative here. And this function is running from 0 to infinite. Then minus the integral of v du. So from this point here, our du is equals to 3 dx. So we shall have our v being negative a third. So the negative a third can bring it out. So okay, fine, negative a third exponential negative 3x, and then v du. If you check, the du is 3 dx, so times 3 dx. So this 3 and we will go. This negative here, we neutralize this one, so we shall have the integral from 0 to infinite 3x exponential negative 3x dx being equal to negative exponential negative 3x from 0 to infinite. Then now it will become plus because of this negative inside the integral. Then we shall have the integral of exponential negative 3x dx. So this runs from 0 to infinite. Now from there, so we are almost done with the mean, that the integral from 0 to infinite of 3x exponential negative 3x dx is equals to negative exponential negative 3x. We shall have negative 1 over 3 exponential negative 3x. Now, and also this one runs from 0 to infinite. Now, so we say that exponential raised power negative infinite to be 0, and exponential raised power 0 to be 1. So in this case, you're going to have, when substitute negative, so you shall have negative exponential negative infinite, then minus, so it will be plus exponential raised power 0, like that, then minus a third, then we shall have exponential raised power negative infinite minus exponential raised power 0. So we shall have 1 minus this other bracket, we shall have, so exponential raised power negative infinite is 0, so it will be negative 1. And so this one here will be equal to 1 plus a third. So and 1 plus a third is the same as 1 and a third. And that will be, so our mean is equals to 1 and a third, or 1.333. Then also Roman number 3, we want to find x running from 0 to 0.5. Roman 3. So if there is any question, you can list the concern in the comment, and then I will look the comment later and I'll answer you. And also, if you want me to add some other information on the same topic, you can inquire in the comment, and I'm going also to come back with a solution for your problem. So Roman number 3. For Roman number 3, we need to require to find the probability x is in between 0 and 0.5. So we said that probability when x is in between a and b is equals to the integral A to be f of x dx. Right. So in this case, let us obtain the integral from 0 to 0.5. Remember, we said that this can only be equal to 1 if maybe that's the given range. But in this case, the range of our function is from 0 to infinite. But we have taken a portion, 0 to 0.5, implying that we will not get equal to 1. So in that case, we're going to have probability when x is running from 0 to 0.5. This will be equal to the integral from 0 to 0.5 of our function f of x, which is 3 exponential negative 3x dx. So when we integrate this, we shall get probability x is running from 0 to 0.5 is equals to, so when we integrate this function, we shall get what? We shall get negative 3 over 3 exponential raised by negative 3x, and x is running from 0 to 0.5. So if we simplify this, we shall get negative exponential negative 3x from 0 to 0.5. So this implies that we shall have probability for x is running from 0 to 0.5 being equal to, so we substitute 0.5 first, so we shall have negative exponential negative 3 into 0.5. Then we minus minus, so it will become plus exponential raised power negative 3 times 0. So we already know what the value of this one will be equal to 1. So here you're going to have negative exponential raised power negative 1.5, then plus 1. So compute, get up to your calculator and compute for the exponential raised power negative 1.5, then plus 1, then you can get the probability. So I'll compute also, so that you can get negative exponential raised power negative 1.5 then now plus 1. So we should get our probability being equal to 0.7769. So that is how we solve a problem of this kind. Unless you have a concern or a question, then kindly just post on the chat, that is on the comment, and then I'll be ready to answer you. So I want so we have started those questions. My students are going to send the questions and I'm going to proceed answering those questions here in Facebook. I don't know why there is a problem. Let me check. Is my live stream available? Or what is happening? So kindly, if you have not joined, kindly join. Any question? Any question here? Okay, thank you. So I want now to proceed to complex numbers, hyperbolic functions, and some part of differential calculus. So if you have a question on PDF, I've already solved one. Maybe I can scroll up, you see what I've done. Then this was the question. The question was a continuous random variable x was given like that as a PDF f of x given by this function. This is the function that you are given. Then you have been told to find or determine the value of the constant k, the mean, and also the probability as x is between the interval 0 to 0.5. So we said for a PDF, it needs to satisfy three conditions: that the integral from negative to infinite of the PDF with respect to x should be equal to 1. And also again, the integral from a to b, the probability of x within the interval a, b of f of x is equals to 1. And also the f of x must be positive or it must be non-negative. So I hope that is clear. So that is what is going to aim at to help us obtain the value of k. And here, that's how you solved for the value of k using that condition. We have been told that x is greater or equal to 0. So it means that x is running from 0 to infinite, positive infinite. And when we integrate, we definitely get negative k over 3 exponential raised by negative 3x for the range of x is 0 to infinite, and that should be equal to 1. So we say that you need to note that exponential raised by negative infinite is equal to 0. Maybe for you to test on that, you can try and check maybe if you can put exponential raised by negative 9999999, it will definitely be equal to 0. So that will tell you that as this exponential gets smaller and smaller, it is going to tend to 0. And we said again, exponential raised power 0 is equals to 1. So basically, you need to know how to do basic integration for you to pursue on probability density function. So I want to shift gears to complex numbers, and then we perform. I have some questions that my students already sent to me, and I'm going to perform them here in this platform, so that also those who have problem on the same, they can follow and understand. If you have not joined or if you have not subscribed to my YouTube channel, kindly subscribe. Thank you very much. So ensure you like and then you share. You like, subscribe, and share, so that also others can also benefit from this. Thank you very much. So if you have any comment, you can go to the chats and you can put your concern there, and then you share to your colleagues. Those will also benefit from the same information or revision. Those who are doing engineering courses, either in colleges or university, they can also join. So it is for all those who are doing some components of mathematics, engineering mathematics. It's for all those who are doing engineering, and also some of those who are doing also real estate and other courses. Those who are also having mathematics, you can put your concern and maybe the topic that you'd like maybe I cover next. So let us go to some questions on complex numbers. Here there is a paper that I have, and I have a question: find the values of. So let me now change this. We go to complex numbers or revision question number. Revision question 1. It says find the value of 2 minus I over 3 plus I then plus 2 plus I over 3 minus I. So these are questions that has been asked, and I want us to solve together. Now, solution. So we should do the solution using the black pen. So let us follow up on this one. So this one is a question on complex numbers. Remember, a complex number is a number. It is a number that can be written in form of x plus y j, where x and y are real numbers, and j is equals to the square root of -1. Don't worry why I am using j instead of I. So in the definition, either I or j is used, but most of the cases j is used, because when you use I, it will bring the conflict that I is also a symbol for, we use I to denote current. So, and therefore sometimes we decide to use j. So both of them serve the same purpose, that is, both of them, they are imaginary number, which is equals to the square root of -1. So in this case, we have some operations on complex numbers. So we can find the LCM of 3 plus I and 3 minus I. Definitely, the LCM will be the product of the two denominators, 3 plus I, 3 minus I. So if you take this denominator, I divide by 3 plus I will remain with 3 minus I. And this 3 minus I will multiply by the numerator, 2 minus I. Then plus, if I take the denominator, I divide by the, if I take the LCM, I divide by the denominator, 3 minus I. I'm going to have 3 plus I, and I multiply by 2 plus I. Now, there are two ways that you can do this question. I shall do with the first method, and then I shall also perform the second method. That is maybe quite simple. Maybe we should check whether maybe it will be simple for everyone. So when you open in the bracket, let us expand 3 minus I times 2 minus I is the same as 3 into 2 minus I, then minus I into 2 minus I. So that one becomes what? When you open up this bracket, 3 times 2, it becomes 6. 6 minus 6I. No, 6 minus. So this one will become what? So you have 3 times 2, which is 6. Then 3 times I to become -3. And then -I times 2 will become minus 2I. And you have -I times -I to become plus I squared. But you know that from the powers, if I is equal to the square root of -1, then I squared is equals to -1. So we are going to have 6, -3 minus 2, it will be -5. I, then -1. So 6 minus 1 is 5. So minus 5I. So that's the first part. And then you can also expand the second part, which is 3 plus I multiplying by 2 plus I. And this is the same as 3, 2. 2 plus I, then plus into 2 plus I. So when you open up this bracket, we shall get 6 plus 3I plus 2I, then plus, now plus I squared. And that squared we said is equal to -1. So we're going to have 5 plus 5I. So that's the second part. Then you have the denominator. When you have A plus B multiplied by A minus B, we know this is the difference of two squares, A squared minus B squared. And so this implies 3I multiply by 3 minus I is equals to 9 minus I squared. But you know what is I squared is -1. So -1 times negative will become positive. So we shall have here as equals to 10. So it has become 10 because of 9 minus -1. Yeah, which is equals to 10. So we substitute. Then we are going to have, when substitute, we're going to have 5 minus 5I, and then plus 5 plus 5I, and then all it's over 10. So when you open up the bracket, you're going to have 5 minus 5I, then plus 5 plus 5I, then over 10. So 5, put the like terms together, you're going to have 5 plus 5, which is 10. Then you have -5 plus 5I, it will be equal to 0. So you're going to remain with 5, it will be equal to 10 over 10, which is simply equal to 1. Okay. Then the other method is to rationalize differently. You solve this one differently, then this one differently. You rationalize, then you put them together. You can try that, then you see what it give us. I hope maybe I'm clear onto that point. So I want us to try the second method on the same question. Then we see what you're going to obtain. Thank you. Kindly subscribe, share, and also you like. So share to your friends, those who are doing engineering. Share to your group, WhatsApp groups, and in your platforms, so that you can do revision together. It's on Saturday. It's on Madaraka Day, guys. I wish you all the best, and I wish you a happy Madaraka Day. So let us proceed to check what is the other method that you can solve the same question. If it will be easy for you, then you will follow. But also, if the first method is also okay with you, you can also use the same method. So let us proceed. We check the other way we can solve the same problem. Method number 2. Method 2, we have 2 minus I over 3 plus I. Then you have 2 plus I plus 2 plus I over 3 minus I. Maybe we could have started by solving the first part, this first part. So let us call this one here part 1. And then we call this one here part 2. So if you do it like that, so let us rationalize part 1. Rationalize part 1. So when you say rationalize, we remember is to multiply the denominator by the conjugate of the denominator and the numerator by the conjugate of the denominator. So that means you're going to have 2 minus I over 3 plus I. Spread the denominator 3 minus I multiply the numerator again by 3 minus I. Then you see what you're going to get here. So in this, when you multiply 2 minus I and 3 minus I, we're going to have 2 into bracket 3 minus I, and then minus I, 3 minus I, then over. So we have said 3 plus I multiplied by 3 minus I, it will be the same as 3 squared, which is 9, minus I squared. But we know what is I squared. I squared is equals to -1. We know I squared is equals to -1, it being the powers of imaginary number. So open up this bracket. 2 times 3 is equals to 6, minus 2I minus 3I, opening now negative I times 3, then negative I times negative I, we shall get positive I squared, and all this over 9 plus 1. So why 9 plus 1? Because I squared is equal to -1. So we shall have, also being this I squared equal to -1, we are going to have 6 minus 1. So we're going to have 6 minus 5I, then plus. So it will be -1 because I squared is equal to -1, and then 10. So 6 minus I is equal to what? -1 is equal to 5 over 10 minus 5 over 10 I. So that's the first part. You can see this part is equals to 5 minus 5 I over 10. Definitely, we have a common LCM, so you can separate to be like this. Then now from there, let us have the second part. The second part is 2 plus I, so rationalize part 2. So if you rationalize the part 2, we're going to have 2 plus I over 3 minus I, and we are going to multiply the denominator by its conjugate, that is 3 plus I, and multiply also the numerator by the conjugate of the denominator, that is 3 plus I. So we're going to have 2 into bracket 3 plus I, then plus I into 3 plus I, over, again the denominators will be multiplying the two brackets. The only difference is negative and positive, so the sign only. So we're going to have 9, then minus I squared. So open up the bracket here, it will be 6 plus 6I, then plus 3I, then plus I squared. Now this far we understand what is I squared. I squared is equals to -1. Then it will be over 10, because this I squared is -1, so negative will become positive. So we're going to have 9 plus 1. So 6 minus 1 will be 5. 5 plus, have we done correct here? Let's see. Have we done correct? So 2 times 3 is 6. 2 times 1, this one is 2. It's not 6. So it will be 2. We need 2 then plus 5I, and then over 10. So which is the same as 5 over 10 plus 5 over 10. So we can now put the two of them together. So adding part 1 and 2. So we're going to have 5 over 10 minus 5 over 10 I plus 5 over 10 plus 5 over 10 I, like that. So this one, the imaginary parts will go, and you're going to have 5 over 10 plus 5 over 10, which would be equal to to 1. So any question, kindly make sure you like, also share to your colleagues, your friends, so that they can also benefit. Thank you very much. So unless you have another question, you can post on the comment. Then we are going to see, and then you see how to do the same question. So we can proceed. Let us proceed to another example. So I'm still using questions. Are there questions that you have already sent? Okay, fine. Let us just go to another question. So we have another question here. So let us just write down the question. Division question 2. You've been given question 2. On division question 2, given that z1 is equals to 4 minus 3i, and z2 is equals to 2 plus I. Evaluate x, y, given that evaluate x and y given that x plus y I is equals to 1 over z1 minus z2, then plus 1 over z1 z2. So here we are required to solve for x and y. So, and in this case, it means that you need to know how to do the subtraction of two complex numbers and multiplication of two complex numbers. So let us go to solution. So we have our z1 is equals to 4 minus 3i, and also we have our z2 being equal to 2 plus I. So I want z2 first. We'll have 4 minus 3i minus 2 plus I. So you need to be very careful when performing the subtraction of two complex numbers, because subtraction is not commutative. Subtraction of complex numbers are not commutative. So be careful, so that when you open up with this bracket, you're going to have 4 minus 3i minus 2 minus I. So this will be equal to 4 minus 2, which is 2, then minus 3i minus 1i, it will be minus 4i. Also again, you also need to perform z1 times z2. So z1 times z2 is equals to 4 minus 3i multiplied by 2 plus I. So, and this we're going to have 4 into 2 plus I minus 3i into 2 plus I. So when you open up this bracket, you'll obtain 8. 4 times I, you'll get plus 4i, then minus 6i, then minus 3i squared. So from there, we know that I squared is equals to -1. We already explained in the previous example. So we're going to have this as equal to 8 plus 4i. Now, what is 4i minus 6? So minus 6i. Then we have minus. It will be plus 3. The reason why it will be plus is because this I squared is already negative 1. So negative 1 multiplied by this negative, it is going to transform the negative to positive. So you put the right terms together to obtain 8 plus 3 to be 11. Then 4i minus 6i to be minus 2i. So already we have now our denominators having been solved. So we're going to substitute. You've been told that x plus yi is equals to, so it will be equal to 1 over z1 minus z2, so which will be equal to 1 over 2 minus 4i, then beta plus, and then plus 1 over z1 z2, which is equals to 11 minus 2i. So again, we have the LCM, or again you can solve the way maybe we had solved the first problem. You can rationalize separately, and then you put the terms together. So you can have this one as equal to the LCM. The LCM is 2 minus 4i multiplied by 11 minus 2i. So if you take this one divided by 2 minus 4i, we remain with 11 minus 2i, and then plus. If you take the LCM, you divide by 11 minus 2i, we shall remain with plus 2 minus 4i, like that. So we can open up the bracket. We have 11 minus 2i, 2 minus 4i all over. So open up the denominator. We're going to have 2 into bracket denominator. If you put the terms together, we're going to have 11 plus 2. We're going to get 13. And then we have minus 2i minus 4i. It will be minus 6i all over. Open up it. 2 times 11, you'll get 22. Minus 2 times negative 2 will be minus 4i. Then minus 4 multiplied by 11, so it will become minus 44i. Then minus 4i multiplied by minus 2i, you'll get minus 8i. It will be plus 8i squared. So from there, we still have our x plus yj being equal to, so we have 13 minus 6i, and this over what is 22? 8i squared to be minus 8. So 22 minus 8 to be what? So we have 22 minus 8 being equal to 14. So we're going to have 14. Then we have minus 4 plus 44. So it becomes minus. So from here now, so that you can write in this form, you need now to rationalize the matter. So rationalize the denominator. We multiply the denominator here by the conjugate, 14 plus 48i. Then multiply also by 14 into 14 plus 40i into 14 plus 48i. And then over, this will become over 14 squared minus. So let us open up this bracket. 13 times 14 will get 182. 182. 13 times 48, 624. So plus 6 24i, then minus 6i times 14. 6 times 14. So we get minus 84i. Then you have minus 6 times 48. You'll get minus 2i. And this over 14 squared. 14 squared is equals to 190, the negative to be positive. So we shall have plus 48 squared. So in this one here, we have squared like that because of it was negative 6i multiplied by 48i. So you're going to have this I squared. So it's going to make this one to be positive. So we're going to have 182 plus 288. We have 470. And then we have 624 minus 84. 624 minus 84. So we'll get plus 540i and all this over 196. And so this one here is the same as we separate 250i. So we can simplify further because we know that 54 over 250 is the same as 0.216. So we can have, and also 47 divided by 250. So we can have x plus yj yi